Let's examine a group of vertebrates that, while less celebrated than apex predators such as lions or raptors, play a critical and often underappreciated role in maintaining planetary health. Specifically, we are referring to amphibians, an order encompassing frogs and toads, caecilians and salamanders. What makes these ectothermic, permeable-skinned organisms so vital to ecosystem function? Let us systematically explore 4 principal reasons for their ecological significance. Firstly, amphibians serve as highly sensitive bioindicators of environmental quality. Their highly permeable integument allows for the direct absorption of water, gases, and dissolved substances from their habitat. This includes not only essential elements such as oxygen and water, but also environmental contaminants and pollutants. Declines in amphibian populations frequently signal underlying ecological disturbances. Such population reductions function as early warning indicators of environmental degradation. In this respect, amphibians are analogous to canaries in coal mines, providing critical insight into the health of wetlands, riparian zones, and forested ecosystems. When amphibians exhibit stress or population decline, it is likely that other taxa, including Homo sapiens, will experience subsequent impacts. Secondly, amphibians occupy integral positions within trophic networks. They function both as effective predators of invertebrates and as prey for a variety of higher trophic-level organisms. Adult amphibians consume substantial quantities of insects, mollusks, and other invertebrates, thereby regulating pest populations. This natural form of biological control reduces the need for synthetic chemical interventions. Additionally, amphibians constitute a significant food resource for birds, reptiles, fish, and mammals. Numerous species, including avian, reptilian, and piscine predators, are dependent on amphibians for sustenance. The removal of amphibians from these systems disrupts ecological equilibrium and can precipitate cascading effects throughout the ecosystem. Thirdly, amphibians play a pivotal role in nutrient cycling and energy flow. During their larval or tadpole stage, amphibians inhabit aquatic environments such as ponds and streams, where they consume algae and detritus, thereby contributing to the regulation of primary production and decomposition. This activity helps maintain water clarity and overall aquatic ecosystem health. Upon metamorphosis and transition to terrestrial habitats, amphibians continue to facilitate nutrient cycling by preying on invertebrates and aiding in the decomposition of organic matter. These processes enhance soil fertility and promote ecosystem productivity. In essence, amphibians function as ecological recyclers, facilitating the transfer and transformation of nutrients. Fourth, amphibians contribute significantly to sustainable agriculture and public health. As natural agents of pest suppression, amphibians reduce the prevalence of agricultural pests. A single amphibian can consume thousands of arthropods annually, thereby limiting crop damage. This results in decreased pest pressure on crops and a reduction in disease vectors such as mosquitoes, which are responsible for transmitting pathogens. These benefits extend to agricultural productivity, food security, and the mitigation of vector-borne diseases. Finally, each amphibian species represents a distinct evolutionary lineage within the biosphere. Amphibians are ancient taxa, having persisted and adapted through extensive geological and climatic changes for over 300 million years. They serve as vital connectors between aquatic and terrestrial ecosystems, a role unmatched by other vertebrate groups. Conservation of amphibians is therefore synonymous with the preservation of ecological networks upon which all life depends. Thus, when encountering an amphibian in its natural habitat, recognize that you are observing a keystone organism essential to ecosystem integrity. It is imperative that we safeguard these species, as their well-being is intrinsically linked to our own.